correlation coefficient. This is basic problems. The first question is the correlation coefficient lies between. It lies between -1 and 1. Second point is if two regression lines coincide, then R is. Let us see. If two regression lines coincide, then R is. I know it's 1, but this is what we're looking for is proof. So mathematically R is +1 if they're perfectly positive, and R is -1 if they're perfectly negative. The relationship between them is perfect. That is something that we can derive from this first part. Second part we don't know, which is why this is going to be between this and that. So we are going to just assume it's going to be +-1. Now if there are two regression lines like this and this, assumingly let's say b of xy is -3/2, b of yx is -1/2, then the whole R comes out to be this is my xy, yes, -3/2, and this is my yx, -1/2. So R is basically, which means it's going to be √3/2. Now it can be plus minus √3/2. We don't know. For a plus minus we cannot state. So on that behalf I will just assume this should be my plus minus, and then I'll take this, because otherwise I have no idea of it, right? So that's going to be my option. If correlation between x and y is 0.4, then correlation between 3x plus and -2y is. Now here the correlation between these two is going to be dependent upon the fact of x and y, right? Now if there are two variables and they are correlated, the degree of correlation is 0.4. Degree of correlation between these two would be how much? Let's see. I have no idea. If there are two variables with correlation 0.4, then correlation between 3x and so yes, the formula basically is suggested right now, that formula for correlation is summation xy whole square upon summation xi square upon summation yi square. So if we change that thing and we add these, what were the variables? 3 and -2. So it will become 4 and 9 here, and this will become like this, and this will again become 4 into 9, and this will become this. So it will still be the same. There's no effect on it, so the correlation remains same, because whatever increase happens will be cancelled out. Now if two regression lines are mutually perpendicular, then correlationship between them is, so if this is my one line, this is my another line, and they have a perpendicular relationship between, I will say it's 0, but let's see. So yeah, simply because see the inferior effects, this is my, if this is my x and this is my y and they are on an xy plane, an increase in x does not bring an increase or decrease in y. It has no relationship whatsoever. Y remains same and x remains same, and for similarly for opposite situations, so there is no relationship between them. So right now we know two things: when it's perpendicular, correlation coefficient is 0; when they are coinciding, correlation coefficient is plus minus 1. Right, now another question, let's go. If pyx is 0.8 minus r is 0.96, st of y is 12. Oh, this is an interesting question. Wait, let me write this on my empty page. If, wait, okay. So the question goes something like, if byx is equal to minus 0.8, r is equal to minus 0.96, standard deviation of y is 12, standard deviation of x is question mark. This is my question, right? Now how to solve this question is the point. Okay, so now we know one thing, that r square is equal to byx bxy and r is equal to root of bxy bxy in itself is equal to covariance of x and y upon variance of x. So here we have covariance of xy upon standard deviation of x to standard deviation of y is equal to 0.96. Standard deviation of x we know is, standard deviation of x is, sorry, y is 12 and standard deviation of x we don't know. Covariance of xy also we don't know. So this, and only this point could have taken you to myself. Now we know this for y, right? So what we are going to do is variance of x. Yeah, y x we know it. We know this for what? Which one? We know y x and we know standard deviation of y. It's quite crazy. We know opposite things. What's the point? Let me put it. I don't know. If b is equal to minus 0.8, r is equal to 0.96, st of y is 12, st of x is equal to in an easy way. So this is the agenda we are after. Yeah, I was sort of there, but I did not really work my way through it. Wait, the answer is still not there. Wait, the answer I don't have. Or is it? correct. Let me see. It is correct. It's none of these. Oh. So intention here is, what is trying to say is, if R is equal, B is equal to R is equal to summation xy whole square. Get it. What it's saying is, it's saying this. Quite a realization. I don't know. Formula is direct, it's not an issue. I want to derive the formula. I will do it in some other video. Don't worry. We will come to this. Wait. Let's ask it. Derive the formula. So this was my BXI. Oh, okay. Oh, we were somewhere there, right here when I did this. It was somewhere here. There's some sort of resemblance, definitely. Yeah. Oh, okay. So if I have this R to be my R, then I can derive this and put this here. That's a genius way to do it. Okay, variance of x, actually, yes. That would mean, wow, okay. So I've derived the formula. Yes, it was there. Okay, minimum value of coefficient of determination is, so I will go with 0, I think. Is it the 0 the correct answer? Yes, it is. Okay, if x plus y is equal to 50, then correlation coefficient between x and y is, now x plus y is 50, I think. For whatever value x will increase, y will decrease. I think the relationship between them is -1. They both cannot be same, so it will be -1. Yeah, it's correct. Okay, now the regression line concerning the two variables x and y are given by, oh, so the regression lines are given. The value of means are, oh, this is, do I have a sheet? I don't have a sheet. Okay, let's do it. If now that we are hell bent on solving the problems, sure, let's do it. So the first equation, wait, let me change my pen. So the first equation is 32 minus x, and the second equation is x is equal to 13 minus 0.25y. Yeah, x is equal to, what I am going to do is multiply this one with 4. So it becomes 4x. 13 fours would be 52 minus y. No, we know this. This has become a khichdi of its own. I'm going to go with this one answer only, and y would be something like 25.3 only. So yeah, this right here is my answer. Okay, then if bxy is 0.2 and by, oh, this is not so complicated. 0.2 minus 1.8 plus minus 0.6. I think, let me check. This is, wait, 0.2, 1.8 would be 3.6. In root. I will go with this only. Let us check once. Wait. If pxy is equal to 0.2 and byx is equal to 1.8, then r is okay. Okay, so this is a rule, which is why, okay. So, wait, so this was also right. If one is negative, both are negative, then r is negative. And similarly, if both are negative, then r is negative. As it said, if both the signs of r this is quite a important point. Can I start this? Wait. Okay, I can't. But yes. Yeah. So if both are negative, it will take a negative sign. If both are positive, it will take positive sign. If one is positive, one is negative, then negative sign. Makes sense. Alright, so this is D, not. Yeah, very important rule. Just discovered it. I'm sorry if somebody's here trying to find the genius. The genius is to be made, not. Yes. So fx y are linearly related, then coefficient of correlation between x and y is x and y are linearly related, then coefficient of correlation between x and y is yeah, it's this only. Okay, we just derived this formula. So byx would be covariance of x and y over variance of x. Similarly, bxy would be covariance of xy upon variance of y. So if I have to have this in numerator, so byx is 1 by 3, this is 5. Okay, wait. Is it a? It's a, correct. Yes, okay. Moving on to the second one. Coefficient of determination cannot exceed. Determination, I think it cannot exceed 1. Yes. Coefficient of determination lies between 0 and 1. Correlation lies between -1 to +1. If this is this and this is this, this is going to be a long solution. Uy is -1, this xy. Let's do this. Wait. If u is equal to 2x plus 5 and v is equal to 1 minus 3y and covariance of u and v is equal to minus 1.2, then covariance of x and y is. Yes, this is going to be my way. I was not as wrong in assuming that means I just did it pretty wrong like that. Okay, it was sort of, I was going the right way. Yes, I was almost right. So again, these sessions are for my self practice. People from future, people from past, do not worry about things that might go wrong. So it will be covariance of uv is equal to ab covariance of xy. So here it's 1.2 and this is a, this is my -3 -6, so it will be -6, this is -2 and covariance of xy. Therefore covariance of xy comes out to be 0.2. Yes. Regression coefficients are affected by change of dash only. I think scale only. Yes, so it's scale. Pearson coefficient is a measure of dash. Coefficient of correlation is a measure of dash linear association. Right, yes. Linear association. Okay, so this would be 1.6 into 0.4. Okay, that would mean 0.8. Now that you know this is positive, so it will be r will be positive. If it was 1 is negative, 1 is positive, then r would be negative. If both are negative, then r would be negative. The sign rule or something that I was not aware exists. No, rise in price and sale. If price rises and sale of, so there's a negative relationship between these two items. Then method of least square yields normal equations. Wait, the answer to this is yes, normal equations. I'm right. If one of the regression coefficient is greater than unity, then the other must be less than unity. Yes. If pxy and this is, so it's going to be same, but it will be minus 0.8. Yes, the sign of regression coefficient is dash as that of correlation coefficient. Same as that of correlation coefficient or dependent upon that. Okay, true and false. Okay, if this is this, I think this would be true. Yeah, this is true because just right now we did this. So here the scale of both a and b is 1, so this would be same. If two regression coefficients are, wait, 1.2 into 0.9 will result in 1.08, it's false. The value of these two must be less than 1. The multiple must be less than 1. The multiple correlation coefficient is non-negative. Correlation coefficient cannot be directly non-negative. Wait, it says false. Wait, let's wait actually. The multiple correlation coefficient is non-negative. True or false? Where is true? Wait. R is explained variation, I don't know. Then R, another point, this also is a very important point. Okay, so this is true. R is always, I had no idea of this to be the case. Yeah, maybe, I don't know. Okay, the correlation coefficient is GM of regression coefficient. I think this is true. Yeah, this is true. Okay, two regression lines never intersect. It says false. So as long as there's no perfect correlation, they can intersect. They can very well intersect and increase or grow. R's xy is equal to 0 doesn't necessarily mean that they are independent. That can be true because see, then what necessarily means a lot of things. So yeah. Okay, so this is my second part. Okay, u is equal to x minus 5, v is equal to y minus 12, r of xy 0.4, r of uv is also 0.4, I think. Wait, is it 0.4? It's 0.4, yes. Yeah, very good. If coefficient of correlation R is then product of two regression coefficients is okay. Product of two regression coefficient is equal to what it's saying is R is correlation coefficient. I think it would be R square. Is it R square? It is R square, okay. If correlation coefficient between x and y is 0.6, then correlation coefficient between 3x and this is change of scale is a relevant phenomena here. So it's going to be fair. It's not going to change of scale is a relevant phenomena in a different situation. Wait, 3 is C. Yeah, wait. Okay. Yeah. So only sign flipping happens here. Okay. Oh, we're back into that zone of trouble. Just solve this. Okay, wait, let's do it. R is equal to I done it right. Wait. Okay, I've done it wrong. Wait, I've done something wrong here. So my formula here was okay. So it's standard of y division of y here, standard division of x here. That would mean this was 4, this was 1.6, and this was my 9. Is this now the correct version of it? Let me see. Wait a second. Still something wrong. Wait. 4r square is 1.6. Oh, this is first of all variance of y. Second of all, this is also going to, this is 9. Wait, I've done something incorrect again then. Wait, I don't know, that fitted so well. I was full in idea of believing it until it didn't work so well. So I think b of xy so this would be my 4, this would be my 6.4, this is my variance of y. Okay, my math was wrong and I was like, I have done something very wrong, I can't figure out what, and I was trying to find salvation in that process. Yes, my math was wrong, my math wasn't mathing. Okay, regression coefficients are independent of change of, I think, origin. Am I correct? Wait, it is fifth part. It's correct, yes. Okay, if correlation coefficient between x and y is 0.9, then correlation coefficient between x and is minus 0.9, I think. Yeah. If correlation, if this is my regression line of y on x, okay, so this would mean minus 2 by 3 plus 2 by 3 actually, plus 2 by 3, and rxy is this variance of this. Okay, why are we doing this again and again? I have no idea, but sure. Variance of y upon variance of x, but I'm glad that we figured this out right in the beginning, so now we have less to worry about. 4 by 9, 1 by 9, 4 variance of y. Wait, I'm thinking, is it d? Okay, so variance of y is 16 and the correct option is actually d only. Okay, if this is my regression line of y on x and x on y, then m cannot exceed. Okay, so byx is m, bxy is 4, 4m is less than 1, so m cannot exceed 1 by 4. Let me check, is it the, oh, I'm right, yeah, it cannot exceed 1 by 4. Okay, so if this is this, oh, quite a thing they have thrown my way. Okay, it's gonna be a long one. I'm not doing this right now. Wait, we'll do this later. Wait. Method of least square gives the normal equation. The principle is to minimize sum of square of errors, right? Yes, limit of multiple correlation coefficient are. Now I think it's 0 and 1. Yes, now that we just discussed. Ax plus by plus c, the relationship between x and y, then rx y equals. Again, if and I don't think like if a is greater than 0, okay, and b is less than 0, so it's basically saying it's x ax minus by plus c is equal to 0. Still, can I say anything about it? It says 1. Probably when x increases, then y would have reduced in a normal case. But here to make it, y can also increase because the sum will be same. Can be said 1, but I am not so sure. I have no idea why. Covariance of x and y is 20. This is this regression coefficient. Oh, 20 by y on x over, I think. Y on x, 20 by 16. 1.25 is it? Wait, let me check. It's not 1.25. Wait. It is 1.25, it's correct. I'm sorry, my bad. I took it a while. This has a full formula now. Okay, let's just dive into it. Give me a minute. The whole formula goes something like this. Okay, what I have to find here is R1.2.3. The formula will be like R1.23 is equal to R12 square R13 square minus 2R12 R21 R23 by 1 minus R23 square, which is why I was not doing this, and we're not going to do this right now. But the answer to this is probably again C. So congratulations on that. With that note, the exercise for this is done. Particularly quite an interesting session.